thought I was done with chapter 12, but I forgot one quick intermolecular force video. Oops. Ion dipole. Okay. Ion dipole. This is an interaction between an ion and a polar molecule, obviously. I should say attraction. Ions and polar molecules. I'm just going to give you one quick example. And really, this is the most important example, is that of an ionic compound dissolving water. Why do ionic compounds dissolve? Well, let's just think about just a piece of sodium chloride. Okay, if we have sodium chloride, it alternates. Whoops, sodium chloride, basically forever. And I'm not going to go on forever. It's just going to feel that way. And, you know, again, we can't really tell which sodium belongs to which chloride. This is a little three-dimensional crystal of salt, okay? So we have the cation and the anion. Now, what happens when we put it in water? Well, what does water look like? Water, of course, has the two hydrogens bonded to the oxygen and the two lone pairs. And that makes this a polar molecule. These guys are partially positive. This one's partially negative. That gives it a net dipole moment in that direction. So it's like a tiny little magnet. And I'm going to draw water molecules as just like a little arrow, okay, just to save time. But just know that everything's still the same. We have the net dipole moment going like that, okay? At the point of the arrow is the oxygen. So if we take a sodium ion with a positive charge and it is in water, well, where's the interaction? What's going to be interacting with that sodium ion? It's going to be the negative end of the water molecules. And if we want, we can draw that little dipole moment on there. We don't really need to, but it's always the negative end, and these arrows point towards the negative. Okay. Sodium is positive, water has a negative end. Well, guess what's going to happen for the chloride? Same exact thing, except in reverse. It's going to be the hydrogen molecules, or the hydrogen end of the molecule, that's going to be interacting with the chloride ion. And the dipole moment will be pointing away from the chloride. I know that one I drew kind of cockeyed, but that's okay, because remember, that hydrogen right there, he's still partially positive, okay? And it's attracted to the chloride. Now, of course, this is not two-dimensional. I drew it two-dimensionally, but this is three-dimensional. So what happens is the water completely surrounds the ions. That forms kind of like a cage around those ions, and they can't get back together. Okay, the sodium and the chloride can't find each other because they're surrounded by water molecules. And that's what makes an ionic compound dissolve. That is it for chapter 12. I'm done until I remember something else.